Hi, my name is Dr. Tian Chi, and I'm an assistant professor of mathematics at MSUB. Welcome to Discrete Structures. So, an overview of what discrete structures is its introduction to discrete mathematics. And what we mean by discrete is not continuous. See, generally speaking, the type of mathematics we do is continuous mathematics. This may be the mathematics you're most familiar with from previous courses, such as calculus. In calculus, we deal with accumulation and rates of change over infinitely small intervals. And being over infinitely small intervals means that there has to be a continuum of possibilities or values that we're working with. But when you're dealing with things like counting whole structures or drawing networks, like these little graphs that you see in the background here, or counting how many ways are there to this or that, the answers or the types of things we're dealing with are not continuous. You can't, for example, say both have you might be able to do something 4 different ways or do something 5 different ways, but not do something 4.75 different ways. And so this course is introduction to topics of that nature. Um, so what I have here is the D2L course shell. What you'll see is an update bar here for when people post in the discussion board. You can go and see what they're doing there. And the course structure broken down into weeks. So if we go ahead to content, in the overview of the course, we will have the course syllabi, including grading scale, breaking down of points, etc. The gradebook is going to be kept here in D2L. So, generally speaking, this is how the flow of the class is going to go. In the first week, I just want everyone to read the first section of the book. The book is Oscar Livin's An Open Introduction. You can download a PDF, purchase a physical copy if you want. Do I have my physical copy up here? Oh, here we go. Yes, you can purchase a physical copy if you want. It should be in the bookstore on Amazon. But of course, my favorite way to interact with the text is through this HTML version. It's free. It's easily readable. If you click through it, there are practice problems at the end through web work that you can do too. It's a really nice setup. Anyway, in the first week, what I want you to do is just to read section 0.1, what is discrete mathematics, and then post in the introduction board and post investigate number 1. And so what we do in investigate number 1 is in this book, most of the sections have an investigate problem in it. It's sort of a prequel to the kinds of things we will discuss within the course. So when you see something like this, these are questions that you may not know the answer to yet, but they're the type of questions that they're either the types of questions we'll answer in that section, or they're build-ups to the type of questions we'll answer in this section. So you'll read this, and then for the first week at least, you'll go ahead and post your thoughts and your attempts at solutions in the discussion board. The solutions aren't going to be great on correctness, but I will grade you on how much thought and the clarity of your presentation you seem to have put into your post. There is a rubric in D2L as well for the discussion boards. For most of the weeks, there will be an introduction here that will describe what is going on in that week, what the goal of that week is. We will ask everyone to do some written assignments. These are proof-based assignments that I encourage you to type up in Overleaf or in LaTeX to turn in. And again, there's a sample tech file here to play around with if you want to see what that looks like. There will be a separate video on that that I'll talk about in a bit. To post about the investigate. And once a week, ask everyone to post about at least one problem that they struggle with. Either a written assignment like this or an affinity problem, which I'll talk about in just a second. But normally what we would, in a face-to-face class, you'd be able to ask questions in class. And then I'll answer, and then other students who also were struggling with that question can get some feedback on that or some help with that as well. Since we don't have that structure, what I'm asking instead is that you post about your questions in the discussion topic, and you post about at least one problem every week. If you really didn't struggle with any of the problems, then go ahead and just post about a problem that you thought was cool or was interesting. So by each Wednesday, I hope everyone will be able to post in both the investigate and the assignment problems. And by the end of each week, I'd like for each of you to respond to at least 2 other people's posts in either the investigate or the assignment problems. Now, I say post at least one problem here, but you can post more if you have more than one question. In fact, we can post all of the problems in the discussion board to be worked on together collectively as a class if we want. I have no problem with that. In fact, that would even be better because then I'd know that everyone was working together to do all of the problems. Now, let's click back here a bit. In each week, there will be assigned Adfinity homework. Adfinity is this front end for web work. Some of you may have seen this in previous classes. I have the due dates listed on the side here. As of the time I'm making this video, the Adfinity people and the D2L people at the university are working it out so that you can access Adfinity directly through D2L. So I don't have a working version of that link just yet. That's hopefully going to be up by Wednesday when you see this. But just to give you a sense of what this looks like, if we click here and open an assignment, and let's preview that. So this is my preview of what you're working on. You can see various problems here that will be due each week. And because I'm the instructor, I don't have this button, but down here somewhere as a student, you will also have a contact instructor button. If you click that, it'll generate a version of the question, an email to be sent to me, and a message you can write there to ask for help on that question. If you do this, then unless you request it specifically, I will post a general response to your question, anonymizing you, of course, in the discussion. That way, all of the students in the class can benefit from the question that you asked, and can also get some help on this question if they're having trouble. Um, in each week as well, I've curated videos on the subjects for that week. This may seem like a lot of videos, but they're very short. They range between 3 to 10 minutes each or so. Like for example, introduction to sets.
The first thing we're going to talk.
Right, we can see that this one's only about just over 4 minutes long. And so I encourage everyone to read the text, which is free, and watch the videos either before or during working through the problems of that week. Now, let's go ahead and talk about the written homework. The written homework in this class is going to be proof-based, which means we're not just doing computations in this class, but we're also writing some mathematical proofs to prove general statements that should hold forever, everywhere. And writing proofs is a form of formal academic writing, and like all formal academic writing, I don't expect you to get it right on the first try. And this is a big reason why I suggest that we use LaTeX or some other similar software to write up our math homework. When you write up a document and you submit it at the end of the week, I will submit it to you with some feedback, and you are welcome to resubmit this homework as many times as necessary to get as much credit on this assignment as you want. My goal for you is to, after a process of revision and reflection and editing, come to a not just a formal, rigorous argument for the thing you're trying to prove, but also develop a sense of understanding on the subject on which you're writing. So every time you do a resubmission, I will ask that you, in the document, write a brief statement about, for each problem that you're revising, what you did wrong before, what you learned in the process of rewriting it, and how you changed it in this resubmission. I have a link here to a sample text file. There is, on the left here, we have the LaTeX code that I use to generate the things on the right. On the right here is the PDF file that it generates. So you write here, and you compile here, and that changes the what's written here. And there's a download PDF button for when you're ready to download the PDF. LaTeX is the standard mathematical typing software that's used in not just mathematics, but in physics and in computer science and other technical fields. So it's I recommend that we all get familiar with it. There is a more detailed video on LaTeXing in this Intro to LaTeX video already in D2L right now. One last resource I would recommend that everyone be familiar with is my website. If you go to my faculty webpage, and there's a link on the syllabus in D2L, go under teaching, go under discrete mathematics. Then there are a number of Sage cells that are really useful for doing computations and for highlighting some of the concepts in this course. So for example, if I hit this permutations button here, what I've done is I found all of the ways I can pick 3 out of 5 objects. We can count them, there's 60 of them, and we can show that that is in fact both the cardinality of that set and that the formula for that computation gives you the same thing. Now, of course, we might not know what any of this means yet. We'll get to that at that point in the course, but I'm just pointing out that this is here for you. All right. So, because of the ongoing pandemic, I understand that this is a very interesting and weird semester. And so, if you need any support on my end at all, if you need help with anything in the course, if you need a date pushed back, if you just need to talk to me through WebEx, please email me, contact me about any issues you might have. We can work it out however we need to. I am here to help. But other than that, I'm really looking forward to this class and to this semester. Welcome to Discrete Math and welcome to Fall 2020. Goodbye.